Okay, so the official title of this section is called Dilations of Functions. We didn't use that word in Math 3 or in Math 2. So actually you guys did learn about dilations a little bit in Math 2 with triangles. You guys would like graph a triangle on the XY plane and then it like gets bigger or smaller. So dilations, basically what we're talking about is how to do a stretch or shrink. Okay, so in Math 3, I forgot to change this, my bad guys, just ignore that. In Math 3, that's messed up too. Does this say that on your guys' too? It's supposed to say horizontal stretches and shrinks. Oh my goodness. In Math 3, we talked about how to do a vertical stretch or shrink. And then we kind of talked about a horizontal stretch or shrink, but we didn't do a lot of graphing with it. In pre-calc, we will. Especially like when we get to the trigonometry graphs in semester 2. Sine, cosine, you guys will learn how to graph those after Christmas. So let f of x and g of x be two functions. G of x is equal to a times f of x. So notice that the a value is on the outside. That tells you that it's either going to be a vertical stretch by a factor of a of the graph of f of x if a is greater than 1. And then g of x is going to be a vertical shrink, which we can also call a compression. You guys will see that word sometimes in math classes. By a factor of a of the graph of f of x if a, specifically the absolute value of a, is between 0 and 1. Why does a need to be the absolute value? Well, what do we know if this first number is like -1? What type of transformation is that? A reflection. Okay, negative automatically means it's a reflection. Okay, so whatever the positive version of this is, if it's like 1/2 or 1/3, then that's when it's going to be a vertical shrink. Okay, so horizontal stretches and shrinks. So now the a value is on the inside. Okay, so g of x we say is a horizontal stretch by a factor of a if a, specifically the absolute value of a, is between 0 and 1. And I should highlight this too. Okay, and then g of x is a horizontal shrink or compression by a factor of a of the graph of f of x if a is greater than 1. Okay, so this is the ones that we do our best in Math 3 to get you guys to understand this, and it's hard. Because, do you guys remember the extra thing you had to do if it's a horizontal stretch or shrink? Because notice, like my coffee did kick in, so I didn't make a mistake. Notice that's a stretch when a is greater than 1 on this side, right? But now it's a stretch when a is between 0 and 1. Do you guys remember that extra thing you had to pay attention to? What's the relationship between the factor and the a value if it's horizontal? You guys remember? If you guys don't know, it's okay. I'm just asking. You guys can say no. They're reciprocals. So like if it's f of 2x, what's the reciprocal of 2? 1/2. And then 1/2, do you guys agree is between 0 and 1? So then if it's 2, it's a shrink. If it's f of 1/2x, what's the reciprocal of 1/2? 2. 2 is greater than 1, so that's a stretch. Okay? All right. And that's only, you have to pay attention to the fact that whatever number is on the inside, if it's on the inside, that's when you have to do the reciprocal. Okay? So note, the factor and a value are reciprocals. Oops. Now, here's the cool part. I always like to see your guys' looks on your faces when we talk about this, because unless you've seen them, they sound scary. We're going to graph trig stuff in the spring, okay? Now, sometimes you guys will graph something like y is equal to the sine of 2x. Do you guys see how the two values on the inside? Okay, if you're wondering like, oh man, now I have to worry about now it's going to be a stretch or a shrink. Whenever we graph trig functions, there's a whole series of steps that we do differently than we do for any other graph. Okay, so yes, it's a shrink, but you won't even pay attention to that because of the steps I'll teach you guys. Okay, and then this will be not that bad to graph. All right, so let's look at the first example, and then they're going to start getting harder. So let g of x, oh man, this is supposed to erase. Let g of x equal 2 times f of x, graph g of x. So the first thing you guys want to pay attention to is where the extra number in the function is located. So is it on the inside or the outside? It's on the outside, right? So is this a vertical stretch or shrink or a horizontal stretch or shrink? Vertical stretch or shrink. So the value 2 is on the outside. So this is a vertical stretch. By a factor of 2. Now just using your brain, vertical, guys, is which direction? Up and down or left and right? Up and down. So you guys agree the y-axis is the up and down axis, right? So that means the graph is either going to get taller or shorter. So if I'm multiplying everything by 2, just using common sense, is it going to get taller or shorter? Taller, right? So all you have to do is pick convenient numbers on this graph, plot points, and then just double the y values. So if I pick this point, this point, this point, and this point, what I'm going to do is just look at how tall each of those points are, what's the y value, and then just multiply it by 2. So if I look at this first point right here, what's the y value of this point? 3. What's 3 times 2? 6. So I'm going to graph a new point where it's the same x value, but now it's going to be at 6. What's the y value here? 0, right? What's 0 times anything? 0, so that point is going to stay the same. What's the y value here? 2. What's what's double that? 4. And then 0 again. Okay, so instead of it doing this, it's going to stretch. So it's going to go like that. So it's going to look like this. Something like that. All right, questions on that? You guys okay? You guys need a day off? You guys know we have a day off coming up, right, in a couple weeks? November 11th. It's just a Tuesday, yeah. It sucks that it falls in the middle of the week this year. I know. They should just give us Monday off too, huh? That'd be nice. So we go to school Monday that week, and then we have Tuesday off, and then we come back to school Wednesday. That sucks. All right. Inside or outside? Outside, so it's vertical again. But just thinking about it, guys, if you multiply something by a half, doesn't make sense, it's getting smaller, right? So this is a vertical shrink. By a factor of 1/2. Okay, so you're going to do the exact same thing. You're going to look at the y values and then just cut them in half. Okay, so if I pick the same points, If I look at this first black point that I drew, what's the y value right here? 3. What's half of 3? 1.5, okay? So I'm going to graph the same x value, so negative 4, comma, 1.5. 0 times anything? Just 0. What's half of 2? 1. 0 times anything? 0. Cool. Are we okay? Questions, comments, complaints, concerns? Are you a Lakers fan? Is that what you asked that? Dude, what the heck? You're not a Dodgers fan too, are you? Okay. I was going to say, huh? Okay. All right. I knew I liked you. You can't like all the bad teams. Yeah, I saw the end because I was watching the Packers and Steelers game. All right, so if we look at example to the first one, now the number's on the inside, right? So that's going to be horizontal. So what we have to pay attention to is because it's on the inside, what we call this number right here, guys, is this is like our A value. So A is 2, but that means your factor is the reciprocal. So what's the reciprocal of 2? 1/2. Now, here's where it gets weird. So I believe last year we decided to not show you guys this because it doesn't come up on the checkpoint. And then we figure if you guys are going to learn it, you guys will see in pre-calc. So here it is. Okay. Horizontal, do you guys agree, is this way? So if I stretched it vertically, I either went away from the x-axis or closer to the x-axis. So now what I'm going to do is I'm going to get closer to the y-axis or further away from the y-axis. So what this means is all you're going to do is take each number right here, each point, and I'm going to multiply by half, but get closer to the y-axis or further away. So this is what I want you guys to do. So same idea, plot your points. So now what's changing is the horizontal distance. So if I look at this first point, guys, how far away from the y-axis is this number right here? Don't worry about that it's negative. Just if I count, how many spaces away is that? 4. What's half of that? 2. So instead of graphing at -4, I'm going to graph it at -2. Okay? This point right here, this number right here is 2 units away. What's half of that? 1. This point right here is on the y-axis, so it doesn't change. Good. This point right here is 2 units away. What's half of that? 1. Okay, so it's kind of like an accordion. That's what I think about. Just like take it and just kind of squish it. So it's going to look like that. Cool. Questions? You guys look so excited to graph. We love graphing. Okay. So what's my A value in the second graph? 1/2. So the factor then is going to be 2. Good, the reciprocal. So same points. But what I need to do now is double the distance away from the y-axis. Okay? So if I look at this first point, guys, we know that this point, remember, was 4 units away. What's double that? 8. So since it's 4 to the left, that means the new point is going to be 4 to the, or 8 to the left. So it's going to look like that. This next point is 2 units away. So if I double that, it's going to be 4 units away. The next point is on the y-axis, so it doesn't change. This next point is 2 units away. What's double that? 4. Okay, so then it's going to look like this. Cool. Questions? No? Okay. Last one for this section. So now the negative's on the inside. So if the negative was in the front, what type of transformation is that? Flexion across what? X-axis. So now the negative's on the inside, so this is a reflection across the y-axis, okay? So this is a special case. So reflection across the y-axis So I'm going to start here, and then I'm going to move my way around the graph. So if I start right here, guys, if I reflect this point across, this point right here is 3 units away. So the new point would be 3 units away from the y-axis on the other side. Okay. This point right here is 1 unit away. So if I reflect it across, it's going to be 1 unit away over here. Okay. So I'm following my graph. The next point would be this point right here. So it's 1 unit away. So if I reflect it across, it's going to be 1 unit away over here. 2 units away. So the new point will be right here. 3 units away. So if I reflect it across, it's going to be over here. So this one actually looks kind of cool. It's going to look like this. Okay, questions on that? Okay. All right. So what's going on here, guys? What does this tell us? What? Vertical stretch by a factor of 3. And then what does that plus 2 mean? Shifting up 2. Okay. All right. So just in the notes, vertical stretch by a factor of 3, and then a shift 2 units up. All right, so I'm going to pick some points. So if I start here, guys, vertical, remember, is either this way or this way because they're going up or down. What's the y value right here? 0. So if I triple that, it's still 0. But then from there, I have to go up 2. Okay. What's the y value here? -2. What's -2 times 3? -6. So I'm going to move my cursor down to -6 and hold it there because I'm still supposed to go up 2. So from here, if I go up 2, it's going to go up to -4. Okay. Y value here is 0. 0 times anything is 0. But from there, go up 2. The y right here is 1. So if I triple that, 1 times 3 gives me 3. So I'm going to hold my laser at 3. And then from there, go up 2. So now I'm at 5. This point and this point have the same y value. So then its outcomes are going to be the same. It's going to land in the same spot. Okay? So this is going to look like this right here. Questions? Okay, let's do this last one, and then we can pause. Okay, this one's terrible. So, according to AP, they suggest that notice that this time we had a 3 on the outside, right? That's a vertical stretch. This time we have a 2 as a multiplier on the inside. So a couple things you could do is you could distribute it, or we can just start on the inside first and then figure it out. They recommend that if it's horizontal, we're going to stretch first, then move. Okay, so I'm going to do a couple things. If you guys have different colors, this might be a good thing to use different colors on because we have technically 1, 2, 3, 4 things we're going to do right now. So the first thing we're going to do is we're going to start on the inside. We're going to do the 2 first, and then what does this mean? Shift to the left. Okay, so I have a 2 as a multiplier on the inside. So the A value is 2, so that means my factor is what? 1/2. So the first thing I'm going to do is, because this is on the inside, this is a horizontal shrink. That means that, if you guys can turn and look at me, that means that the graph is shrinking towards the y-axis going like this. So what I'm going to do is, I'm going to use different colors. I'm going to first shrink each of these points closer to the y-axis before I do anything else. So right here, this point right here, let me draw my points first. Right now, this point right here, how far away from the y-axis is this point? 3. What's half of that? 1.5. So I'm just going to draw a point right there. I'm not going to draw any graph. I'm just going to plot a point. This right here is 1. What's half of that? 0.5. This point right here is 1 away. So half of that is half. This point right here is 2 away. What's half of that? 1. And then the last point is going to be 1.5. Okay. So is everybody cool with that? So what I have in green is just the shrink. Okay. From there, now I need to take each of these green points and do what? move to the left. So I'm going to pick up each of these points, and I'm going to slide it 3 units to the left. Okay? So I have my iPad, so I'm going to just drag them. But if you guys have a different color, I would now use a different color and move them 3 units to the left. So if you guys even have a highlighter, maybe just like highlight each of your steps. So now I'm going to take each of these points and move it 3 units to the left. So 1, 2, 3. Is that right? Yeah. Oh, I didn't mean to do that. That doesn't work because the black points move too. I don't want to do that. So I'm going to use blue. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. So I've taken care of the 2, and I've taken care of the +3. Okay? So now, when there's a negative in the very front, what type of transformation is that? Reflection across the x-axis. So now what I'm going to do is I'm going to reflect each point, and then after that, what does this mean? Up 1. Okay, so I'm going to do both those steps at the same time. So starting here, I'm going to use purple. Starting here, this point's on the x-axis, right? So if I reflect it, does anything happen? Nope. So then up 1. This point right here, this point is 2 units away from the x-axis. So if I reflect it across, it's going to be right here. Up 1. This point's on the x-axis, so nothing happens. And then up 1. This is 1 above, so if I reflect it across, it'll be 1 below. And then up 1. On the x-axis, nothing happens. Up 1. Okay. So now you have to think about what I'm doing. Okay, so it's going to look like this. I don't like that. There we go. And then... That's a hard one. It's a lot of work. Now, I obviously can't tell you guys what to do, but I highly recommend, at least like when I was in college, this really helped out. In high school, I would just use pencils and be okay. But as the farther you guys go into math, when I would take my notes, I would use different colored pens. I would have highlighters. I even got to, I'll turn this off.